North Africa. March 1943. Temperature at midday, 118 degrees. Through German field glasses, Lieutenant Klaus Hartmann watches an American supply column crawling across the Tunisian desert. The Americans are pitching canvas tents in a war zone where Stuka dive bombers make daily runs and sandstorms shred anything not made of steel. Hartmann lowers his binoculars and turns to his radio man with a crooked smile. They bring tents to fight a war. As if this were a camping trip in the Bavarian Alps. Around him, his men laugh. The Wehrmacht has been fighting in North Africa for 2 years. They know what the desert does to canvas. It rots in heat, stakes pull loose in sand, and when wind comes, tents become kites. The Germans live in concrete bunkers, stone buildings, steel dugouts. The idea of sleeping in fabric strikes them as absurdly American. Hartmann had been at Kasserine Pass 2 months earlier when Green American troops broke under the first German assault. The canvas tents fit perfectly into that narrative. Soft soldiers, soft equipment, soft thinking. What Hartmann doesn't know is that those tents aren't permanent housing. They're temporary accommodation for troops who will be moving into something else within 48 hours. Something the Germans have never seen before. Something that will make their concrete bunkers look medieval by comparison. April 1943. Sicily. Feldwebel Otto Klein finds himself on reconnaissance patrol near Bizerte. Through binoculars, he sees row after row of identical structures in the American encampment. Not tents, not buildings, something else. They look like massive steel barrels cut in half lengthwise and laid on the ground. Each one perhaps 15 meters long, painted olive drab. Klein counts 47 of them, with more being assembled. He sketches what he sees. The structures appear hollow, offering no obvious blast protection. His report reads, "Enemy has deployed prefabricated steel structures of unknown purpose. Possibly storage facilities. Defensive value, questionable." The intelligence officer files it with a note. Enemy field expedience. No tactical significance. This assessment will prove catastrophically wrong. The first German prisoners to be processed through American-controlled territory provide the real glimpse. Oberfeldwebel Hans Meyer, captured near Tunis in May 1943, walks into a POW processing center consisting entirely of these half-barrel buildings. A corporal who speaks German answers his unasked question. Quonset hut. Took 6 guys about 8 hours to put up. We've got about 200 of them in this camp. 8 hours. Meyer does the mathematics. A German barracks requires 20 skilled men working a week, plus materials transport and foundation work. 8 hours seems impossible. Lieutenant Hartmann, who laughed at tents in March, finds himself captured in June. He spends his first night as a prisoner in a Quonset hut holding 80 men. Hot during the day, but retaining warmth through freezing desert nights. He stares at the curved steel ceiling. Somewhere in the dark, another German officer whispers, "How many of these do you think they have?" No one answers. If the Americans can produce these by the thousand, ship them anywhere, assemble them faster than bombs can destroy them, then the war the Germans thought they were fighting ended somewhere back in the mathematics of industrial output. The Quonset hut isn't just a building, it's a statement. We can put a weatherproof structure anywhere on Earth faster than you can destroy it. The laughter from March seems very distant now. December 10th, 1941. Pearl Harbor still smolders. In Washington, D.C., Brigadier General Eugene Raybould stares at a map of the Pacific covered in small American flags, marking outposts needing immediate reinforcement. Each flag represents hundreds or thousands of soldiers who need housing. Not eventually. Now. His chief engineer delivers the grim assessment. Traditional barracks construction requires skilled carpenters, concrete foundations, lumber that doesn't exist in most Pacific locations, and approximately 6 weeks per building. We need to house 50,000 men in advanced positions within 3 months. Using conventional methods, we might complete 20% of that requirement. What about tents? Canvas disintegrates in tropical conditions. Average lifespan in monsoon climate is 3 to 4 weeks before the material rots through. The mathematics are brutal. Permanent construction is too slow. Temporary shelters are too temporary. And the Japanese aren't waiting. The Pacific Theater isn't just hot, it's a laboratory of everything that destroys buildings. Wake Island sees typhoons with 130 miles per hour winds. Guadalcanal receives 200 inches of rain annually. Alaska's Aleutian Islands experience -40 temperatures. Building codes written for Kansas become irrelevant when your construction site is a volcanic island being bombed while monsoon rains turn everything to mud. This is the impossible equation. Design a structure that ships flat, weighs less than a truck, requires no foundation, assembles in a day using soldiers with no construction experience, costs almost nothing, and survives every hellish condition the planet can generate, and produce 10,000 in 6 months. Any sensible engineer would say it can't be done. Quonset Point, Rhode Island, January 1942. Inside a drafting room, a small team huddles around blueprints and rejected designs. Team leader Otto Brandenberger examines British Nissan hut specifications from World War I, semicircular corrugated iron structures that house troops in France. The genius. An arch naturally distributes wind loads and sheds water. The corrugated metal acts as both skin and skeleton. The flaws, too heavy, requires concrete footings. Ventilation designed for French winters creates ovens in tropical heat. But the core concept is sound. Take the British arch. Strip away what doesn't work. Rebuild it to American specifications. Brandenberger starts with materials. Corrugated steel provides strength through geometry. 22-gauge galvanized steel, thin as a quarter, can handle structural loads if corrugated properly. The arch shape creates what engineers call a compression ring. Every point pushes inward against every other point, making the structure inherently stable. A 16-foot wide semicircular arch provides 7 feet of headroom at walls, 8 feet at center. The 40-foot length provides 720 square feet, enough for 36 men with bunks. Foundation work is eliminated through brutal simplicity. The structure sits directly on the ground. Total weight, 9,000 pounds. Assembly is designed for the lowest common denominator. Panels are stamped with codes. Panel A-1 bolts to panel A-2. If you can read numbers and turn a wrench, you can build it. Wooden end walls come pre-framed with doors mounted. Slot them in, bolt them down. By February, they have a prototype. A giant steel tunnel, industrial and utilitarian. The first field test happens during a February nor'easter. Winds gusting to 60 miles per hour, 15 degrees, snow turning to sleet. 6 sailors assemble the structure in 7 hours and 12 minutes. That night, Brandenberger's team sleeps inside. Wind howls, snow piles up. Inside, with a simple heating stove, the temperature stays comfortable. The structure flexes slightly but holds. No leaks, no failures. The impossible equation has been solved. Now they just need to build 10,000. By March 1942, scattered across the industrial Midwest, steel fabrication shops receive orders for thousands of identical corrugated panels. Strand Steel Corporation in St. Louis becomes primary manufacturer. The government contract specifies 8,000 complete units by September. That's 45 per day, every day, for 6 months. Production chief Harold Watkins sees a manufacturing challenge unlike anything before. Each hut requires 96 individual steel panels in 6 different profiles. Traditional methods would require hundreds of workers. His solution: specialize every operation, minimize handwork, continuous flow. Raw steel coils arrive by rail. Automated rollers corrugate sheets. Hydraulic presses punch bolt holes with positioning jigs guaranteeing consistency. Conveyor systems move panels through zinc galvanizing baths. At the far end, finished panels stack on shipping pallets. By May 1942, the St. Louis plant produces 60 complete huts per day. Additional manufacturers come online across Pennsylvania, Ohio, Indiana. By June, production hits 180 units daily across all facilities. That's 1 complete Quonset hut every 8 minutes, 16 hours a day. The convoys sail through U-boat-infested waters. Lose 3 cargo ships but get 2 through, and you're still ahead of conventional construction. Liberty ships carry roughly 40 disassembled huts per voyage. Pacific bases receive first deliveries in July. Samoa gets 200 units. New Caledonia receives 150. Assembly instructions are printed on waterproof cards with illustrated steps. 12 steps total. A crew of 6 can assemble a complete hut in under 8 hours. Some crack teams get it down to 4 hours. Guadalcanal, August 1942. Henderson Field falls into American hands but remains under constant Japanese attack. Marine engineers unload components under sporadic shelling and begin assembly in a coconut grove. 12 hours later, Henderson Field has 10 new structures. 3 days later, a Japanese bomb detonates 40 yards from a hut full of mechanics. The blast wave flattens surrounding palm trees. Canvas tents would have shredded. The Quonset flexes, and when smoke clears, the structure stands intact. Every man inside is shaken but alive. The jungle proves as hostile as enemy action. Within 2 weeks, rust streaks appear on ungalvanized fasteners. Salt air eats through hardware. Fungus grows on everything. Marines start cutting additional vent holes, violating specifications, but making the huts livable. These field modifications get sent back to Quonset Point, incorporated into later production runs. By December 1942, monthly production exceeds 8,000 units. The Americans are building a Quonset hut every 5 minutes. German intelligence officers reading these figures dismiss them as propaganda. No industrial system can possibly manufacture housing that quickly. They're wrong. By 1943's end, American factories have produced over 100,000 Quonset huts. That's housing capacity for nearly 4 million soldiers. No army in history has ever fielded logistics at this scale. Sicily, July 1943. Within 48 hours of American invasion landings, rows of steel structures rise from the beaches. Oberst Karl Richter, observing from German positions in the hills, counts them through field glasses. 51, 73 by 1,400 hours. That's roughly 2,500 men under cover, plus supply storage. How long have they been ashore? 31 hours. The mathematics don't compute. German construction battalions need days to establish fortified positions. The Americans are doing it in hours, using ordinary soldiers following instruction cards. That confidence is its own message. August 1943. Lieutenant Wolfgang Becker's demolition team reaches an abandoned American supply depot outside Palermo. The site contains 30 intact Quonset huts. Orders: destroy everything. He tries fuel first. 5 gallons of gasoline splashed across interior steel, then ignited. The fire roars, steel heats up, but the structure doesn't collapse. When fuel burns out, he has a blackened but standing building. Demolition charges then. 4 kilograms of TNT at the base. The explosion scatters panels across 50 meters. None are particularly damaged. Given fasteners and hours, this could be reassembled. The Americans have built structures that are difficult to permanently destroy because they're designed to come apart. German forces retreating from Sicily encounter captured Quonset huts in POW camps. Feldwebel Ernst Schmidt, a trained carpenter from a pioneer battalion, examines them with professional interest and growing unease. A German barracks requires 20 skilled men working 6 to 8 days, costs 12,000 Reichsmarks. This American structure costs 8,000 Reichsmarks equivalent, requires 6 unskilled men working 1 day, appears functionally equivalent. If the Americans can produce these at scale, ship them anywhere, assemble them faster than they can be destroyed, then the war has shifted into industrial capacity dimensions that no amount of German battlefield skill can overcome. Winter 1943-44. The Italian campaign grinds northward. Through captured binoculars, German observers see Quonset hut cities appearing behind American lines. Hundreds of structures organized in neat rows, turning valleys into instant military installations. All assembled in days, all weatherproof, all positioned to support continued operations. Major Hermann Kruger watches American preparations for the Monte Cassino assault. He writes his wife, "They build faster than we can destroy. Our artillery hits their depots, collapses those steel tunnels, and within 2 days they have rebuilt. It's as if they have infinite capacity. Our bunkers, built by skilled engineers over weeks, represent irreplaceable infrastructure. Their structures appear overnight like weeds. This asymmetry extends beyond replacement rates. German positions require extensive planning, material transport through narrow mountain roads, skilled labor that's increasingly scarce. American positions require flat-pack components that move easily, unskilled assembly labor that's infinitely replaceable, and construction times measured in hours. By early 1944, German intelligence has comprehensive documentation. The technical assessment concludes the design is crude but effective. representing American preference for quantity over quality. That phrase becomes a catchphrase, repeated up the command structure, meant dismissively. What it actually describes is why Germany is losing the war. Quality doesn't matter if you're outnumbered 20-1. The Americans have solved warfare by turning it into a production problem. One Obergefreiter, drinking schnapps in a rear area tavern, summarizes the feeling. We built Europe's finest fortifications, concrete meters thick. And the Americans, they beat us with glorified tin sheds that 6 farm boys can assemble in a morning. There's a lesson in that. The lesson, though unspoken, is becoming clear. Germany approached war as a test of military excellence and warrior culture. America approached war as a logistics challenge requiring industrial solutions. The Quonset hut represents which philosophy prevails. December 17, 1944. Philippine Sea. Super Typhoon Cobra hits Admiral Halsey's Third Fleet with winds exceeding 140 miles per hour and waves that dwarf destroyers. 3 destroyers sink. Nearly 800 sailors die in one of the Navy's worst disasters of the Pacific War. On Leyte, the Typhoon makes landfall with apocalyptic force. 20-foot storm surge. Palm trees snap like matchsticks. At Tacloban Airfield, 127 structures stood before the Typhoon. When it passes, 89 buildings are completely destroyed. Another 24 damaged beyond repair. Of 43 Quonset huts on base, 39 survive intact. 4 suffer repairable damage. The corrugated steel arch performs exactly as designed. Wind flows over the curve rather than slamming into flat surfaces. Even damaged panels can be replaced individually without tearing down the entire structure. 3 days after the Typhoon, recovery crews are reassembling salvaged panels. Within a week, Tacloban Airfield has regained operational capacity using rebuilt Quonset huts that would have required months to restore using conventional construction. The Navy's Engineering Bureau releases formal assessment. Quonset-type structures demonstrated superior survival characteristics in extreme weather conditions exceeding design specifications. The jungle environment, initially viewed as hostile, actually proves ideal. Termites that devour wooden buildings in months ignore corrugated steel. Monsoon rains slide harmlessly off galvanized panels. Problems emerge, of course. Steel conducts heat mercilessly. Condensation forms on interior surfaces. Sound conducts, making rain deafening. American ingenuity solves these through field modifications. Sunscreens made from palm fronds shade the steel. Interior canvas liners reduce condensation. Sound dampening comes from sand-filled burlap bags. None appear in official specifications, but all get incorporated into later production. The Arctic proves equally severe testing. Alaska's Aleutian Islands experience -40 temperatures, 100 miles per hour winds. Early deployments reveal weaknesses. Cold makes steel brittle. Panels crack at bolt holes. Engineers respond with cold-rolled steel with different metallurgy, rubber gaskets at joints, entrance vestibules to prevent snow buildup. By 1944, Quonset huts in Alaska outperform permanent buildings. The flexible design handles freeze-thaw cycles that crack concrete foundations. The curved roof sheds snow that collapses flat roofs. The European theater provides bombardment testing. German artillery regularly targets Allied bases. Direct hits destroy Quonset huts, obviously, but near misses, explosions within 50 yards that collapse wooden buildings, often leave Quonset huts damaged but standing. More importantly, when destroyed, they fail gracefully. The panel system means collapse happens, component by component rather than catastrophically. Combat engineers develop rapid repair procedures, carry spare panels and bolts. A 3-man crew can replace damaged sections in under 2 hours. The Americans treat Quonset huts like consumable supplies, expecting damage, planning for it, maintaining inventory. By 1945, field performance data from 50 combat zones feeds back to manufacturing. Production models bear little resemblance to 1942 prototypes. Better ventilation for tropics. Improved insulation for Arctic. Stronger fasteners everywhere. Enhanced anchoring for typhoon zones. Naval Seabees discover that two Quonset huts placed end-to-end create enormous covered spaces perfect for aircraft maintenance. Air Force mechanics discover that with doors fully open, the curved ceiling creates natural smoke evacuation for welding. The Navy repurposes them as dental clinics, bakeries, radio stations. By May 1945, over 160,000 Quonset huts have been deployed worldwide. They house roughly 6 million personnel. They've survived typhoons, artillery, Arctic winters, tropical heat, earthquakes, and constant hard use. They cost an average of $1,394 each. A conventional barracks costs $12,000 and requires weeks to construct. The mathematics are brutal and beautiful. The Americans have solved military housing by treating it as a manufacturing problem. The Germans, who laughed at American tents in March 1943, spend the last months of war retreating past Quonset hut installations, stretching from the Rhine to the Elbe. The steel tunnels follow advancing Allied forces like a tide, appearing overnight, representing everything the Wehrmacht cannot match. Quality versus quantity. Engineering sophistication versus mass production. The Quonset hut doesn't win architectural awards. It wins the war. May 8, 1945. Victory in Europe. August 15, 1945. Victory over Japan. The United States military owns roughly 170,000 Quonset huts, scattered across 6 continents, and has no idea what to do with them. Original assumption: these are temporary wartime structures that would be scrapped once permanent facilities could be built. That assumption crashes against unexpected reality. Nobody wants to get rid of them. Commanders look at their Quonset huts and see perfectly functional buildings that cost nothing to maintain and can be repurposed for anything. The War Assets Administration faces an unusual problem: more demand than supply. Veterans return home to a housing shortage so severe that families live in converted chicken coops, share apartments with 3 other families. The construction industry can't build fast enough. Into this crisis steps the Quonset hut, available for civilian purchase. $1,000 to $2,500 for a complete structure that would cost $8,000 to build conventionally. By late 1946, suburban developments made entirely of Quonset huts spring up around every major city. Long Island sees entire neighborhoods of curved roof homes. Chicago's outskirts feature Quonset suburbs housing thousands. Los Angeles converts them into apartments, shops, churches. The architectural establishment is horrified. These utilitarian military structures represent everything professional architecture opposes. One prominent architect calls them the death of residential dignity. Residents don't care. They have roofs, weather protection, space for growing families, costs far below conventional housing. Some paint them cheerful colors, landscape around them, add porches and windows. The Quonset hut proves remarkably adaptable. Agricultural use proves especially popular. Midwestern farms add Quonset storage for grain, equipment, livestock. Maintenance is minimal. Hose off the exterior annually, check bolts occasionally, and the structure lasts indefinitely. Quonset huts become embedded in American visual culture as symbols of practicality over pretense, function over form. They appear in movies and television as shorthand for post-war optimism mixed with austerity. International aid organizations discover the Quonset DNA keeps reappearing wherever rapid deployment matters. The 2010 Haiti earthquake destroys Port-au-Prince. Relief efforts face familiar challenges. Immediate shelter for hundreds of thousands, no infrastructure, no time for conventional construction. Solutions borrow directly from Quonset principles: arched steel frames, corrugated panels, prefabricated components that ship flat. The formula hasn't changed because underlying physics and logistics haven't changed. The UN High Commissioner for Refugees uses shelter systems called RHUS, essentially Quonset huts with 80 years of material improvements, insulated composite panels instead of corrugated steel, snap-fit connections instead of bolts. But core concept remains identical: curved profile for structural efficiency, self-supporting arch, flat pack shipping. Assembly by unskilled labor. These units currently house over 200,000 displaced persons in refugee camps across Africa, the Middle East, Asia. Hurricane-resistant construction has rediscovered arch geometry. After Hurricane Katrina, engineers studying which buildings survived found curved structures consistently outperformed rectangular ones. The Mississippi coast saw entire neighborhoods reduced to foundation slabs, while Quonset-style metal buildings stood intact. The modern tiny house movement unknowingly reinvents Quonset principles when designers seek maximum interior space with minimum materials. Several companies manufacture arch-roofed prefab cabins using the same corrugated metal and self-supporting curve that Otto Brandenburger pioneered. Military applications never stopped. U.S. armed forces still deploy arch-style shelters in conflict zones. Afghanistan, Iraq, classified locations all feature modern descendants. Current specifications call for units that can be helicopter lifted, assembled in combat conditions, survive IED blast waves. Materials have evolved: aluminum alloy frames, Kevlar reinforced panels, climate control systems. But if you showed a 2025 military deployable shelter to the 1942 Quonset Point team, they'd immediately recognize their own design philosophy. Recent innovation includes expandable versions that deploy from shipping containers, unfold like origami, lock into rigid arch structures within an hour. The economic argument that justified Quonset huts in 1942 remains compelling today. When disaster strikes or rapid deployment is required, conventional construction cannot compete on speed or cost. A modern engineered arch shelter delivers weather protection for approximately $50 per square foot. Conventional construction in same conditions runs $150 to $300 per square foot and requires weeks or months. The mathematics haven't changed. Fast beats slow. Simple beats complex. Good enough beats perfect if good enough arrives 3 months earlier. Lieutenant Klaus Hartmann sits in a displaced persons camp outside Munich in October 1945. The war is over. Germany is occupied. His uniform is gone, replaced by civilian clothes too large for his frame after months of reduced rations. The building he sits in is a Quonset hut, one of thousands the Americans brought to Germany as occupation forces established bases. The same curved steel ceiling he once dismissed now provides the only shelter between him and approaching winter. He watches American soldiers assembling another hut outside. 6 men, basic tools, 7 hours from start to finish. He's seen this process dozens of times now, each viewing adding another layer to his understanding of how thoroughly he misread American capabilities. The laughter from 1943 seems impossible now. How could he have been so blind? The tents were never permanent. The Americans weren't naive. They were solving a different problem than German intelligence assumed. Not how to build the best shelter, but how to build adequate shelter, faster than any enemy could destroy it. Around him, other former Wehrmacht soldiers share the space. Conversations circle the same themes. How did it all go so wrong? Some blame leadership. Others point to tactical errors. A few insist Germany was simply outnumbered, but Hartmann keeps returning to the Quonset hut, not because it's significant in itself, but because of what it represents. The Americans didn't just outfight Germany. They outproduced Germany so completely that the fight became mathematically impossible. Every destroyed American position rebuilt overnight. Every lost aircraft replaced within days. Every shortage solved by manufacturing more. The Quonset hut is a symbol of that capacity. Simple, crude, unglamorous, and absolutely unstoppable. The Germans built concrete bunkers that took weeks and required skilled labor. The Americans built steel tunnels in hours with semi-trained soldiers. War isn't decided by who has the best equipment. It's decided by who can sustain operations longer. The Americans demonstrated they could build faster than Germany could destroy, produce faster than Germany could consume, replace faster than Germany could kill. Hartmann will spend the next 3 decades occasionally encountering these structures. Each time he sees that distinctive curve profile, he'll remember standing in the Tunisian desert, watching American positions through field glasses, and laughing at their apparent incompetence. The laughter stopped somewhere between then and now. The realization, painful and complete, is that the joke was never on the Americans. Adequate solutions deployed at scale defeat. Perfect solutions deployed in limited numbers. Fast beats slow. Simple beats complex. And industrial capacity, properly mobilized, renders tactical brilliance increasingly irrelevant. The Quonset hut won't appear in official histories of World War II. Too mundane, too utilitarian, too too far removed from dramatic battles. But it should appear because it tells a truth about modern warfare that military academies struggle to teach. Wars are fought by soldiers, but won by factories. The side that can produce faster, replace faster, sustain longer ultimately prevails, regardless of tactical skill or individual courage. Hartmann eventually returns home to rebuild his life in changed Germany. The Quonset hut remains behind, one of millions of pieces of American material culture now scattered across the world. But all of them carry the same message, the message that made German soldiers stop laughing in 1943 when they finally understood what they were facing. Not tense, not crude engineering, not American naivety. They were facing an industrial power that had solved warfare by turning it into a production problem, and production was something America understood better than any nation on earth. When you see one now, remember what it represents. Not just shelter, but the moment when modern warfare became less about soldiers and more about supply chains, less about tactics and more about logistics, less about fighting well and more about lasting longer. The Germans laughed at American tents. Then they saw Quonset huts, and the laughter died in their throats as they began to understand, too late, what industrial war actually meant. Alamogordo, New Mexico, 2024. A faded curved steel building sits at the edge of an abandoned military training facility. Corrugated panels showing decades of weathering, but still fundamentally intact. This particular Quonset hut was assembled in 1943 as temporary housing for troops training for the invasion of Europe. 81 years later, it still stands. Temporary, it turns out, is relative when applied to properly designed structures. Engineers specified a service life of perhaps 10 years. They didn't account for the arch shape's fundamental stability, the galvanized steel's corrosion resistance, or simple inertia keeping buildings standing because no one bothers to tear them down. Across America and worldwide, thousands of Quonset huts persist. Some maintain active use. Others sit empty, monuments to expedience that outlived its purpose. A few have been repurposed so many times that current occupants have no idea of their military origin. Dr. Sarah Chen, architectural historian at MIT, has documented surviving Quonset huts and their current uses. Churches, artists' studios, storage facilities, workshops, homes, breweries, restaurants, community centers. The curved steel profile appears in contexts its designers never imagined. What's remarkable, Chen explains, isn't that they survived. It's that they remained useful. The basic design is so flexible that each generation finds new applications. The 1940s needed housing. The 1950s needed affordable homes. The 1970s needed cheap industrial space. The 2020s need sustainable, adaptable structures. The Quonset hut served all these purposes without fundamental modification. Some military bases kept their Quonset huts long past planned obsolescence, discovering that old steel buildings outperformed newer construction in durability and maintenance. Fort Lewis, Washington, has Quonset huts from 1943 still in active service. Annual maintenance consists of inspecting bolts and touching up rust. That's it. Compare this to conventional buildings requiring regular repair of foundations, roofs, electrical systems, plumbing. The Quonset's simplicity becomes an asset. No complex systems to fail. Just steel panels, visible fasteners, straightforward maintenance. The environmental movement has discovered Quonset huts as early examples of sustainable design. Minimal materials, adaptable function, long service life, easy repair, ultimate recyclability. A Quonset hut at end of life becomes tons of recyclable steel, not landfill-bound composite materials. Modern architects, after decades of dismissing Quonset huts as eyesores, are rediscovering their potential. Several high-profile sustainable building competitions have featured Quonset-inspired designs. The American Institute of Architects' 2023 retrospective included an entire section on Quonset huts. The accompanying essay concluded, "We spent 50 years trying to forget these buildings existed. Now we're realizing they solve problems we're still struggling with. Those problems remain fundamentally unchanged. How do you provide adequate shelter quickly and affordably? How do you build structures that adapt to changing needs? How do you minimize materials while maximizing durability?" The Quonset hut answered these questions in 1942, and the answers remain valid. In disaster zones worldwide, the Quonset design language continues appearing. After the 2023 Turkey-Syria earthquake, relief organizations deployed arch-style shelters that would look familiar to any World War II veteran. Materials are modern, assembly methods improved, but geometry is identical. Climate change has added new urgency. Rising seas, stronger storms, increasing displacement require shelter solutions that are mobile, durable, rapidly deployable. The physics that made Quonset huts ideal for 1940s military operations make their descendants ideal for 2020's climate adaptation. Researchers at University of Colorado have developed modern arch-style shelters using composite materials in parametric design, but the fundamental concept remains unchanged from Brandenburger's 1942 calculations. One researcher notes, "We thought we were innovating. Then we looked at historical precedents and realized we were just rediscovering principles military engineers figured out 80 years ago." The Quonset hut's greatest legacy might be demonstrating that good design doesn't require complexity. The arch shape, corrugated panels, bolt-together assembly, and foundation-free installation all represent solutions so elegant they've become essentially timeless. Not because they're perfect, but because they're adequate for a remarkably wide range of applications. This adequacy is itself a kind of perfection, not the perfection of form or aesthetic excellence, but the perfection of function, solving the problem at hand with minimum resources and maximum adaptability. In an era increasingly concerned with sustainability, material efficiency, and climate adaptation, these virtues look more valuable than ever. German soldiers who mocked American tents in 1943 have long since passed. The Wehrmacht's concrete bunkers, engineered for permanence, mostly succumbed to post-war demolition or natural deterioration. The temporary American steel tunnels they dismissed outlasted the entire German Reich and continue serving purposes undreamed of during their creation. There's a lesson in that persistence, not about military superiority or national character, but about design philosophy. Build for flexibility rather than permanence. Favor simple solutions that can adapt over complex solutions that can't. Prioritize function over form. Accept adequate performance achieved quickly over perfect performance achieved slowly. These principles, embodied in a structure designed during desperate wartime urgency, remain relevant precisely because they weren't tied to specific circumstances. The Quonset hut worked in 1943. It worked in 1953, 1983, 2003, and works today. Not because it's perfect, but because it's good enough. And good enough is often the most valuable kind of solution. The curved steel silhouette, once the target of architectural scorn and German mockery, has become an icon of American pragmatism. It says, "We solve problems efficiently. We build what works. We don't waste time on aesthetics when people need shelter. And what we build, utilitarian as it may appear, lasts." Somewhere in Tunisia, if you know where to look, you can still find traces of American encampments from 1943. The tents are long gone. Fabric returned to dust decades ago. The Quonset huts, dismissed by German intelligence as temporary expedients, remain. Weathered, rusty in places, repurposed by local farmers or abandoned to the desert, but fundamentally intact. They outlasted the soldiers who assembled them, the war they served, and the empire they helped defeat. They stand as monuments to the idea that sometimes the best solution is the simple one, adequately executed at massive scale. The Germans laughed at American tents. History records that laughter and what came after. The tents were never the point. The Quonset huts were the point. And 80 years later, they're still making it.